In this video, we're going to look at permutations and probability. Use permutations to calculate the following probabilities. Write your answers as fractions and percents rounded to 4 decimal places. So let's look at the first question. The student council has 14 students. They need to choose a president, vice president, secretary, and treasurer for the student council. In how many ways can the 4 different positions be appointed from the 14 students? So notice here here are our choices. We need to choose a president, vice president, secretary, and treasurer. Now let's look at the number of options. So there's a formula for this for permutations in general, but let's try to connect that to this counting idea. Okay, well, let's say it doesn't really matter which one we choose first, but we do have 4 distinct positions, and a student can't be both president and vice president. We'll assume that even though they didn't say it. So when we go to choose the president, there's 14 students available. But now we've chosen one of the students. We don't know which ones, but when we go to choose the vice president, there are 13 options available. For the secretary, we've chosen 2 already. So we have 12 options, and for the treasurer, we have 11 options. Okay, so basically, this is like a without replacement or a dependent situation. Okay, or a can't repeat the student situation. Those are the 3 ways we refer to this, and each one of them, the number of options decreases by 1 as we continue on. Okay, the formal notation for this is 14p4. That means we're taking the number of permutations of 14 objects, which is students, taken 4 at a time. Okay, let's calculate this number, and your calculator has a button for this, but we're just going to do it old school. 14 times 13 times 12 times 11. So there are 24,024 ways to do this. Okay. Now the next question is the probability question. There are 4 seniors in the high school. If the students are randomly assigned to the positions, what is the probability the president is a senior? Okay. So notice we're finding a probability now. We found the total number of ways that these positions could be filled, okay, by any student. Now we're going to specifically find one where this president is a senior. So since there's 4 seniors, when we go to choose the president, we only have 4 options. Okay. Now, how many options do we have for the vice president? Well, we've chosen 1 senior, so now these could be anything, seniors through freshmen, but we have 1 less option, so this will be 13, and then again 12 and 11. Okay. We would denote this 4 times 13p3. And we could even say that this is 4p1, meaning we have 4 seniors and we need to choose one of them, but we won't be that fancy. Now, let's write this out as a ratio. So we have 4 times 13 times 12 times 11 over, instead of writing this, I'm going to write the factored form, 14 times 13 times 12 times 11. Now you can see a lot of these factors cancel. The 11s cancel the 1, the 12s, the 13s. We're left with 4 over 14. They actually have a common factor of 2. So I'm going to write this as 2 over 7. So that's our fraction form. And now let's write that as a percent. So 2 divided by 7 times 100 is 28 point, what did we say, 4 decimals? Let's just do 2, 28.57%. Let's look at the next one. James is creating a 4-digit passcode using the digits 0 through 9. And we are asked, how many 4-digit passcodes are possible if the numbers can be repeated? Okay, so notice this is not a permutation, this first part, because if the numbers can be repeated, then this is a fundamental counting principle problem. We have 10 options for each of the 4 choices. So we have 10 times 10 times 10 times 10. or 10 to the 4th, which is a 1 with 4 zeros, or 10,000. Now the next part is a probability, and it asks, James chooses all of the characters at random. What is the probability that no digits are repeated? So not repeating digits, that means, just like with our last permutation, we're going to start with, well, we have 10 digits to start for our first digit. Okay. But now our second digit, we have one last choice, one less choice, then we have 8, then we have 7. Okay. So this in permutation notation is 10p4. The number of permutations, you have 10 things taken 4 at a time. Okay. Let's write this as a ratio. So we have 10 times 9 times 8 times 7 over 10 to the 4th. I'm going to write out all the factors. And we can simplify this a little bit. Again, you can do this on your calculator. The 10s cancel. 8 has 2 factors of 2, so 8 divided by 4. So I'm just going to cancel out that factor of 2 with this 10, and another factor of 2 with this 10. Oops, I should have said 3 factors of 2, and another factor of 2 with that 10. Okay. Sorry, this is a little messy, but what's left on top, these 10s canceled. 8 is 3 factors of 2, so I canceled out a factor of 2 from each of the 10s, leaving 5s. In the numerator, we just have 9 times 1 times 7, which is 63. In the denominator, 5 times 5 times 5, which is 125. Okay. Again, I just wanted to show you how to do this by hand, and you'll always have usually have a lot of canceling that will happen, but you can do that on your calculator if you want. And now to write it as a percent, 63 divided by 125 times 100, 50.4. So 50.4%. So about half of the passcodes won't have any repeated digits. We have one last one. Okay, and this is a card problem. 3 cards are chosen without replacement, so that helps you know it's a probability, or a permutation, excuse me, from a deck of 52 cards and placed in order from first to third. And the order matters. That's a permutation requirement too. We'll see something that doesn't have order coming up soon. So first we're asked how many outcomes are possible. Well, we'll start with 52 cards. Then we'll have one less because there's no replacement. We've already taken out 1 card. And then we have 50. So this is 52 permutations taken 3 at a time. And if we multiply these 3 numbers, we get 132,600. So that's the total number of possible outcomes if you consider it a first, second, and third card. Now here we're asked for a probability, and it says, what is the probability the first card is a club? Well, we know that since we're just going to count the event space, we can't simplify yet. We'll simplify later. So there are a total of 13 clubs. Okay. For the second card, okay, the second and third don't have any restrictions, but we used 1 card. We know it was a club. So there's 51 cards left, and then 50 cards for the third. Okay, so we just had less options for the first choice. Now, if we write this as a ratio, on the numerator we have 13 times 51 times 50. The denominator is all the possible options. Okay, and again, notice a lot of these are going to cancel. The 50s cancel, the 51s cancel. 13 divided by 52, you should remember they each have a factor of 13, and this should look familiar. So we have 1/4, which is 25%. So 1/4 of the possible outcomes will start with a club because 1/4 of the cards are clubs. Now let's look at the last one. What is the probability? So this is going to ask for specific outcomes for each of the choices. We have ace, king, and queen. Okay. But notice there are 4 aces, 4 kings, and 4 queens. So each one of these is going to be 4, which is 4 to the third. Okay, so we have 4 times 4 times 4 over 52 times 51 times 50. Okay, I'm actually noticing we weren't asked to write this one as a fraction, so I'm just going to go ahead and do it on the calculator. So we have 4 raised to the third power divided by, and 52p3. If you're going to do this on the calculator without this final number, put everything in parentheses, but since we know it, I'm going to type 132,600. Okay, and notice this is a very small number. Okay, I'm actually going to multiply it by 100 first. Basically, that e to the negative 4 means move the decimal 4 places from here to the left. So it would be decimal 3 zeros 48, but let's just go ahead and multiply by 100% first. That way, hopefully, we don't have to move that in our head. Okay, so this is a percent value. Okay, and 2 decimals, I'm going to go to 3. Let's go to 4 here. So 0.0483. 0.0483%. Okay, and again, on your homework, you'll be told what decimal place to go to, and you go to that. Here in this situation, I wanted a few more extra digits just to see the rest of the probability.